Is my screen is visible?
Yes, ma'am.
Yes, ma'am.
Yeah. So this is the course content for week 2. In this, we have covered lecture 1 and lecture 2 and the lecture 3 of Laplace transform definitions and how to solve find a Laplace transform of different signals using definition of the Laplace transform. Right now, this week we will let me write. Uh, this is week 2 content and today's date is 26/06. Okay, so in this class, we will discuss about some of the finding Laplace transform using the properties of the Laplace transform. You all, I think you all have gone through these properties and all in the signal system. Am I right? Okay, good.
Yes, ma'am.
Yeah, nice. Uh, let's solve one problem using properties of Laplace transform because in control systems and all we will have signals that are it will be useful if you remember the properties based on rather than solving using first principle of that means integral using the definition of Laplace transform. So, for example, we will solve one problem so that we can understand how it will be easy if you use properties of Laplace transform. Let us find example. Find the Laplace transform of x of t equal to t minus 2 whole square e to the power of minus 2t. mm, Sorry. Yeah, before going to this one, I wanted to ask you one question. How many of you know Fourier transforms? Uh, Good. Now, can you tell me what is the difference between Laplace transform and Fourier transform?
Fourier is defined for discrete signal.
Hmm?
Fourier transform is
Huh?
defined for discrete
Define
signal.
for, is it? Can't we find Fourier transform for continuous time
No, no,
signal?
no, no. It is Laplace is for bounded signals,
Uh-huh.
and Fourier transform is for unbounded signals also, like finite or infinite.
Uh, okay. Another
Laplace
thing?
is a special kind of Fourier transform.
Mm-hmm. Good. Yeah. What else? Yeah, actually, I wanted to say is uh, Laplace transform is not a special kind. It is a generalized version of generalized method of converting time sinusoidal signal into frequency domain signal. Why? Because we are having S is equal to sigma plus j omega, right? Sorry, j omega. That means um, Fourier transform definition is uh, Fourier transform of f of t is minus infinity to infinity f of t e to the power of minus j omega t dt, right? Whereas Laplace transform of f of t is minus infinity to infinity f of t e to the power of minus st dt. That means minus infinity to infinity f of t e to the power of minus sigma t into e to the power of minus j omega t dt, right? So here this part e to the power of minus sigma t, you know, e power minus j omega t, it is nothing but cos omega t minus j sin omega t, right? So that means here represented this part is a sinusoidal representation of signal, whereas this part it will tell how these sinusoidals are growing or decaying. Let us suppose if your sigma is greater than 0, then e to the power of minus sigma t. That means it is decaying function, right? So this signal it will tell like how the magnitude of these sinusoidals are changing. That means your sinusoidals are increasing function or decreasing, exponential increasing or exponential decreasing, right? This is a much better way of representing signals. Like Fourier transform, we are only focusing on V naught cos omega t or V naught. Uh, so V of t. Let's say suppose your signal is V of t. General representation is V naught cos omega t, right? This is a sinusoidal function. But now you are representing how this magnitude is changing with respect to time, not only the frequency. So that means V naught e to the power of minus sigma t cos omega t. So this is telling how your sinusoidals are damping with respect to time. So this is more generalized version of Fourier transform. Clear?
Yes, ma'am.
Hmm. Yeah, right. Now let's go to our problem, um, finding the Fourier transform. Sorry, finding Laplace transform of your functions x of t equal to t minus 2 whole square e to the power of minus 3 into t minus 2 u of t minus 2, right? So in this I am going to use the following properties. One is time shifting property. Can anyone tell what is the time shifting property? Can you remember? Okay. I'm telling the time shifting property of Laplace transform is like this. Laplace transform of x of t minus
Yes,
t.
like
Pardon?
shifting time is multiplied by frequency exponential.
Yeah, good.
Decrease exponential.
Yes, that's right. E to power of minus st naught x of s. Yeah, the Laplace transform of the signal is multiplied with e to the power of minus t naught. Good. The second property which I'm going to use here is in a differentiation property. What is this? Laplace transform of t power n x of t equal to minus 1 whole power n dn by dsn x of x of s. Okay. Now I'm going to use these two properties to solve this problem. So the first thing is I wanted to remove the time shifting. Without shifting, I wanted to write, let's say x of t equal to f of t minus 2 u of t minus 2. This part I'm calling as f of t minus 2, where f of t equal to t square e to the power of minus 3t, right? Now we can use what is the Fourier. Now we find the Laplace transform of the signal. Now I am using differentiation property to find this one. Now f of s is nothing but your Laplace transform of f of t equal to using differentiation property, it is minus 1 whole square d square by ds square of this signal. This is Laplace transform of e power minus 3. What is that one?
1 by s minus 3.
1 by s plus 3.
Good.
S minus.
It is s plus 3. So 1 by s plus 3. Then it will be d by ds of 1 by s plus 3. Differentiation is minus 1 by s plus 3 whole square. Right? This is
Yes.
equal to s plus 3 whole power 4 minus, then this is 0 minus 2 into s plus 3. So which is equal to 2 by s plus 3 whole cube. Right? Now the Laplace transform of, now we will you apply the time shifting property. That means this one. Then Laplace transform of x of t e to the power of
Minus 2s.
minus 2t into f of s, that is 2 by s plus 3.
2s, ma'am. 2s minus 2s e to the power minus 2s.
Oh, yeah, right. Therefore, it is e to the power of minus 2s into 2 by s plus 3 whole cube, right? Yeah, nice. Uh, Next, we'll see other problems like final initial value theorem and final value theorem. Those are also very much important in solving next time domain analysis and all. Uh, can anyone know what is that initial value theorem?
Limit s tends to infinity,
One second.
then f of s.
Limit s tends to,
S tends to infinity.
let me, one second, x of t, initial value theorem, right? This is
S
limit
S
t tends to 0, x of t is equal to limit s
S
tends to
tends
infinity,
x of
yes,
s.
yes, x of
Yes,
s.
x of s.
Yeah, right. Is that any other things are there? That's it.
It is a condition based. If
What
t
is
is,
that condition?
it should be defined in greater than
Uh,
u of t or u of minus t.
u of
If it is t is greater than 0, then this condition. If t is less
uh,
than 0, then it is reversed. Like
okay. And what else? There is one important condition is there. Here the condition is x of t should be strictly proper function. You know what is proper function?
bounded.
Function is said to be proper function. That means the numerator, that means x of, sorry, this is x of s should be proper function. This is x of s. It should be proper function. What does this mean? It means the highest power of denominator should be greater than numerator. Let's suppose if you are having s plus 1 by s square plus 2s plus 1, this is a proper function. Okay, this is a strictly proper function. Okay, if it is numerator and denominator both are of high same power, then we say that this is not a strictly proper function. Why we need this kind of condition? Let's see. Uh,
Ma'am, for the previous question, I have doubt
huh,
in differentiation,
uh,
double differentiation.
okay,
D by dx of minus 1 by s plus 3 to the square is, it minus minus becomes plus here, so it is minus 2 by s plus 3 whole cube.
minus 2 by now. So this is
Yes,
0, right? First
yes.
one, keep denominator constant and numerator. So minus 1 I have already taken out here.
And again differentiation, it will become minus, one more minus will come.
Uh, why one more minus?
1 by, if I take
Let
1
me see.
by s plus 3 to the whole square as 1 by s plus 3 to
No,
the
no.
s plus 3 to the whole s plus 3 as a t, if I take
Bu, this is 1, right? If it is like this, uh, then
1 by minus
you
1 by,
keep the numerator constant u v dash minus v u dash by v square, right?
yes ma'am.
Uh, so here s plus 3 is the s plus 3 whole square. Sorry, s plus 3 whole power 4 over 9. Here we are keeping numerator. Is it correct?
Otherwise, we can consider 1 by s plus 3 as a t variable. So 1 by
Uh-huh.
t to the power 2, uh,
Mm-hmm.
a differentiation of that is minus 1 by t to the power 4 2t.
Yeah, correct, correct. Right.
Yes.
Mm-hmm. Yeah, correct.
So it will become minus.
Right, right. Yes. So this is minus. Okay. Yeah, nice. Yeah, now let's go to this problem. Let's take one a problem of for finding initial value theorem. Um, Let us say given x of s is equal to 5 by s plus 2 into s plus 3. Now tell me whether this is a strictly proper function or not. This is a proper function or not.
Yes, ma'am, it's a proper function.
Yeah, yeah, this is a proper function. Now you wanted to find initial value. That means limit x tends to 0, x of t is equal to limit s tends to infinity s 5 by s plus 2 into s plus 3. This is equal to, mm, we can take s common here, limit s tends to infinity s into 5 by 1 plus 2 by s 1 plus 3 by s into s square. This is the answer. So we can say uh, this is 0, right? This value will be 0. This is 0. This is 0. Then we have one more s here. So s tends to infinity means you will have this is 0. So the initial value we can even verify uh, by computing inverse Laplace transform for this one, right? X of t. How do you calculate? By using partial fraction. S plus 2 plus b by s plus 3. Uh, can you tell what is a and b by comparing the quotients? Uh, it is put s is equal to minus 2 in this expression, right? Then you will get 5 by 1, that is 5, plus, now substitute s equal to minus 3 in this one. Then you will get minus 1, minus 5. So this is 5 by s plus 2 minus 5 by s plus 3 is equal to 5 into e to the power of minus 2t minus 5 into e to the power of minus 3t. So if t equal to 0, limit initial value, right, we have wanted to find. So limit x tends to 0 x of t equal to 5 minus 5, that is 0. So you got the same answer here also, right? Now we'll take another example. Is it clear what I'm doing?
Yes, ma'am.
Yes, ma'am. But ma'am,
But
Ah,
here
I think that
on
that previous question you were correct. The differentiation one.
okay, okay, okay.
There should not be minus.
Okay, okay. Fine, fine. Let us take another function which is not proper function here. Let us
Ma'am, here,
take
can you explain proper function means once again? Only
proper function means uh, the the highest power of numerator degree should be less than uh,
okay, okay, ma'am, got it.
denominator. Let us take, I will tell you now, I will give you one example here. Here I am choosing some function s plus 2 by s plus 1. Is it a proper function? This is not proper function because numerator highest power of numerator is equal to denominator, highest power of denominator. So this is not a proper function. We can write this as 1 plus 1 by s plus 1. Am I right? So what will happen if you apply initial value theorem here? Limit s tends to infinity, yes, x of s in this case will be limit s tends to infinity s into 1 plus 1 by s plus 1. So this is equal to infinity. Am I right? Now, suppose if you calculate x of t here, because here you are having 1. 1 means the inverse Laplace transform of 1 is delta, right? Plus e to the power of minus t u of t. Isn't it? Now, if you find the initial value for this function, limit t tends to infinity, or I can say directly x of some x 0 plus. 0 plus means here t value will be 0, e to the power of this one, this is 1, right? This is not equal to this infinity. Is it clear? So, to apply initial value theorem, you need to check whether x of s is a proper function or not. Now, let's go ahead with the final value theorem. Are you clear? You have any doubts?
No, ma'am.
Good. Because I'm not able to see your responses in the screen. That's the reason I'm asking you. Now, can anyone tell the formula of mathematical representation of this final value theorem?
X of t, t tends to infinity.
Limit t tends
Limit
to infinity, x of t
x of t equal to
is
s
equal to limit
s
tends to 0.
0
Yes, yes,
s x of s.
yes. Good. Um Now, is that enough, or you have any other constraints or conditions here?
Same, ma'am. It should be proper.
Proper? No. Here the conditions are different. You know poles and zeros? Poles.
Yes, ma'am. Poles and 0.
Yeah, right. Yeah, the poles should be lie in the left half of the S plane. For x of s, poles of x of s should be left half of a S plane. Left side.
Means it is a finite.
Yeah, right. It is a finite segment. Correct. Second, another constraint is there can be have zeros, sorry, pole at 0, but that should be only single pole. Can have single pole at 0, at s equal to 0. Okay. So these are the two conditions it has to satisfy. Let us take some example here also. Let x of s is equal to 2 by s into s plus 3. Then final value of this is equal to x of t limit t tends to infinity is equal to limit s tends to 0 s x of s, that is equal to limit s tends to 0 2 by s plus 3, that is equal to 2 by 3, right? We can even verify with by computing inverse Laplace transform of x of t. What is x of t? It is equal to yes, put s equal to 0 in this equation, then you will get 2 by 3 plus put s equal to minus 3 in the remaining part of after removing s plus 3, then it is minus 2 by 3. That means 2 by 3 into 1 plus e to the power of minus 3t. So limit t tends to 0, sorry, t tends to infinity, right? So your final value tells limit t tends to infinity x of t is equal to 2 by 3. So both are matching. Let us suppose if you are having one pole on the left half of the S plane, right half of the S plane. Another example, x of s is equal to 1 by s minus 1 into s plus 3. So limit s tends to 0 s x of s is equal to limit s tends to 0 s by s minus 1 into s plus 3, which is equal to 0. Right? Now x of t, what will happen? X of t is equal to s minus 1, put s equal to 1, then you will get 1 by 4 s equal to 1, you will get 1 by 4 plus s plus 3 minus 3. If it is minus 3, then 1 by minus 4, minus 1 by 4. That means 1 by 4 into e to the power of t plus, sorry, minus 1 by 4 into e to the power of minus 3t. So it's clearly showing that as t tends to infinity, x of t is equal to infinity. So the system is unbounded. So final value is infinity. But your theorem showing it is 0. So you can't use final value theorem if you are having poles in the left half of the plane. And another thing is if you have multiple poles at origin. Suppose what will happen if you have multiple poles at origin, that means it will be s square term will become like this, right? Here you will get like s cube plus 3. So if you, what is the Laplace transform of 1 by s square? You will come, you will have some t, right? So t means as t tends to infinity, it will become infinity. It's an unstable. Okay. Is it clear now? Now we'll go to solve some more problems of solving system responses using how do you find system response. Yes, last week we found how to find the system response using convolution integral, right? Now we'll go to using how do you find system response using Laplace transform. So you are having a system whose response is y of t for the input x of t, and h of t is impulse response. Then response of system, we saw that y of t is x of t convolution with h of t. Right. Now how do you find the using Laplace transform? What are the steps? Well, we know the property of convolution, right? Convolution in time domain is multiplication is frequency domain. So what you do first, we have to find out y of s, x of s. Find the Laplace transform of x of t and h of t. Then multiply both together. You will get y of s. Then you will get y of t is inverse Laplace transform of y of x. That is equal to, that's all. So this is the way we can find Laplace transform inverse system.
Here, here we have to define that ROC also for the
Yeah, right. Yeah, while calculating inverse Laplace transform, we need to take care of ROC. Based on that, you need to find the signal. Let's say, for example, in this course, mostly we'll deal with right-handed signal. So don't bother about that part now. Let us take one example. Find the system response find the system response y of t given h of s. h of s is directly given, is given s plus 1 by s square plus 2s plus 2. And your signal x of t, this is in time domain, another one is frequency domain. Right? X of t is defined as e to the power of minus mod t, where t tends to minus infinity to infinity. Okay. Now find the y of t of this signal. Now x of t is having mod function. You know mod function definition, right? What is mod? It is equal to t for t greater than 0, and it is minus t for t less than 0. Right? Now, first step is we need to find out x of s and h of s and x of s. X of s is not given in this problem. We need to find out. Now, Laplace transform of x of t is equal to x of s. Now, I am using the first principle, or you can use direct formulas also, properties also. This I am writing x of t as, first I will write x of t. E to the power of minus t u of t plus e to the power of t u of minus t. Right? One is left-handed, another one is right-handed signal. Now Find out x of s.
1 by
Hmm.
s plus 1.
Good. 1 by s plus 1 plus
This is 1 by
uh,
s plus 1 only, but
1 minus s.
1 minus s.
Right?
And
Good.
yes,
This is equal to 2 by 1 minus s whole square.
the h of
S into x of s is nothing but 2 by this I am writing as 1 minus s into 1 plus s into h of s is s plus 1 by s square plus 2s plus 2. I can cancel out this one and this one. Then we will get 2 by 1 minus s into s square plus 2s plus 2. Now inverse Laplace transform of this one. We need to use partial fractions, right? So first we'll I am writing this one as first itself I am
s
converting into
plus 1
partial.
whole square. S square plus 2s plus 2 is s plus 1 whole square.
S plus 1 whole square cancel, right?
No,
Where?
no, no, I am telling here like s1
Okay, this
minus
part. Okay, this part. Let's go. First, let's divide into partial fractions. Then we'll go through that one. Let this is one. I'm actually writing. Yeah, this is I'm writing as 1 minus 1. Sorry, s minus 1 plus bs plus c by s square plus 2s plus 2. Now you can find out what are the quotients for this one. Let's after doing comparing the quotients of these two from here, this equation with this equation, then you can find a is equal to 2 by 5, b equal to 2 by 5, and c equal to 6 by 5. You can verify this one, right? You want me to show?
no ma'am will verify.
Yes. Now y of s is equal to minus 2 by 5, 1 minus s. I am writing as no, this s minus 1 is a comfort one. I think this is minus 3. Yeah. Now minus 2 by 5 s minus 1 plus 2 by 5 by s plus 6 by 5 by s square plus 2s plus 2. That is equal to 2 by 5 by s minus 1 plus, if I am taking common, s plus 3 by s square plus 2s plus 1. This part now I am expanding what you said before. Minus 2 by 5 by s minus 1 plus 2 by 5 into this I am writing as s plus 1 2 by, sorry, this is s plus 1 whole square plus 1, which is equal to minus 2 by 5 by s minus 1 plus 2 by 5 into s plus 1 by s plus 1 whole square plus 1 plus this by s plus s plus 1 whole square plus 1. Now y of t is equal to the inverse Laplace transform of this function e to the power of minus 5 e to the power of minus t plus 2 by 5 into e to the power of minus t cos t plus 2 e power minus t sin t. Got it? Is it clear?
Yes, ma'am.
Good. So you have any doubts as of now?
No, ma'am.
Okay. Now we'll do one simple problem using solving ODEs. Because in all the systems we are encounter in control systems are based on dynamical system, which we represented using ordinary differential equations. So in this case, we will take one example of RL circuit finding solving ODEs using Laplace transform. Um, So the first thing is we need to write the differential equation, then use Laplace transform for dy dt differentiation. Then you find the Laplace transform function. Then you calculate the inverse Laplace transform. That's all, right? So let's take one example. We are having a one RL circuit. This is plus a capacitor, one RC circuit. So capacitor, let's assume it is having 0.5 microfarads and this is 2 ohms. And the input here Vi is equal to 10 U of t. Now what is the voltage across the capacitor? Vc of t you need to find out. Now apply KCL, sorry KVL. Vi of t is equal to R into I of t plus Vc of t. I'm directly writing instead of writing 1 by c integral I dt. I'm writing Vc of t. Where Vc of t capacitor voltage, what is formula for capacitor voltage?
1 by c integral of
Uh, mm,
is t by
1 by c integral I dt,
I.
right? Mm. Or current I of t, what is the I of t? Capacitor current through the circuit I of t or current through the capacitor. C dvc by dt. Now I'm substituting this into here. Then you will get R into C dvc by dt plus Vc of t. Let's assume I'm one more condition. I'm actually let the capacitor is not rest. That means the voltage across the capacitor at 0 plus initial voltage is some 2 volts. I can add that one also here in this. Now apply Laplace transform on both sides. apply LT on both sides. Then Ci of s is equal to RC is 0.2 into 0.5, right? That is 2 into zero point 0.5, that is 1. 1 into S Vc of s minus Vc 0 plus Vc of s. So that is, here input is 10 times u of t, that means 10 by s is equal to, I am taking Vc of s common,
No, man.
s plus s plus 1
Something.
minus 2, right? V naught is 2. Initial Vc voltage across the capacitor is 2. So Vc I have taken common, then it is s plus 2. Now what is Vc of s? Vc of s, it will be 1 by s plus 1 into 10 by s plus 2. That is equal to 10 plus 2s by s plus 1 into s. Now apply partial fractions. Now s means put s equal to 0 in this equation. Then you will get 10 here. Now for this one, s plus 1, put s equal to minus 1 in this equation. So that means 10 minus 2 by minus 1, that is minus 8. So V of t is Vc of t. The voltage across the capacitor is 10 minus 8 into e to the power of minus t. So this is the application of Laplace transform to solve the differential equations. Do you have any doubts with this? It's clear, right?
Ma'am, can you share this PDF in?
Yeah, sure, definitely I'll share you. Is it right? No? Yeah, with this, the
10
week.
U of t. It should 10 U of.
Yeah, you can write it 10 V of t, that is fine. Good. Yeah, you're responding. That's right. I like this class actually. Otherwise, it's kind of a one-way discussion. I don't like that way because we are having an opportunity to have live classes. We should be interactive. Good. So with this week 2 class, you have any doubts, you can contact me anytime, and you can post it in the disclose so that I can respond. It's fine, right?
Ma'am, is there any surprise quiz?
Yeah, surprise quiz I will give you. Let me stop sharing my screen. Yeah, in the disclose, you are actually asking for G meet, right? One G form so that we can track all the sessions, right? So that's why I created a form. I will share in the chat box. Let me open my G form link. I created a one link. I have shared you in the here. In the I created a form. So there I have given the one problem. So you will have 20 minutes time. Try to solve that problem and take the picture of it and upload that page to that G form itself. Is it fine?
Yes, ma'am.
Yes, ma'am.
Yeah. You will have 20 minutes time from now. You can take. Okay. I'm closing the session today. See you. Happy weekend. Have any doubts?
Thank you.
Yeah. Fine. Thank you.